Hello, Algebra 2. Here we are with inverse matrices. Inverses undo each other. So for addition, 5 plus a negative 5 equals 0. They undo each other. They kind of cancel each other out, leaving us with 0, which is the additive identity. 2 times a half equals 1. Kind of canceling each other out there in terms of multiplication, leaving us with 1, which is the multiplicative identity. And then another type of inverse that we have, x squared and square root, they cancel out, leaving you with just x. But our first two, they undid each other and left us with the identity for each operation. So when we're multiplying matrices, it should lead us to the identity matrix 1, 0, 0, 1. And just like up here, they're called the identity because if we add 0 to something, it doesn't change it. It stays that something. 1 times 10 stays at 10, so that keeps its identity. If we take 1, 0, 0, 1 times another 2 by 2 matrix, then that other matrix would stay the same. Okay, and here's your 3 by 3. Notice the pattern here, just a diagonal of 1s with zeros everywhere else. If two matrices are inverses of each other, they should multiply to be 1, 0, 0, 1. So let's see how this works. We're just going to be given two matrices, and we're going to test it with this property, that they should multiply to 1, 0, 0, 1. So yes, we have to do matrix multiplication again. I like to do a little oversized matrix for our work matrix. Remember, we're going row times column. So we got 3 times 3/4 for 9/4, and negative 5 times 1/4 for a negative 5/4 in that top left corner. And those add together or combine together to be 4/4, which is 1. All right, that's going to be 4/4 up there. Next one, row times column. 3 times 5/8, 15/8. Negative 5 times 3/8 for negative 15/8. And 15/8 plus a negative 15/8 is 0. Bottom row. Negative 2 times 3/4, we'll have negative 6/4. 6 times 1/4 is 6/4. And those would cancel out to 0. Ooh, we're almost there. 1, 0, 0. Hopefully we get a 1. Row times column. Negative 10/8. And 6 times 3/8 is 18/8. For 8/8, which is 1. 1, 0, 0, 1. They are inverses. All right. Let's have you push pause there and try the next one and see if it's an inverse. Okay, let's see how we did. I got no, not an inverse. Let's take a look. Row times column, we'll have negative 4 times 1/4. That's 4/4, negative 4/4, which would be a negative 1. And then 2 times 1/2, which would be 2/2 or 1. So a negative 1 and a positive 1 is definitely going to be a 0. Row times column. Okay, so technically we had a 0 in that first spot already, which does not match our 1, 0, 0, 1. So technically not inverses already. You could stop right there. But we want the practice. Row times column. We'll have positive 4/2, negative times a negative, so positive 4/2, and then a negative 2, for 0. Row times column, we'll have negative 2/4 and positive 1/2. Negative 2/4 is the same as negative 1/2, so that's going to cancel out. We'll have another 0. And here we'll have positive, negative times a negative. We'll have a positive 2/2, which is 1, and a negative 1, which is 0. So that's how we got a matrix full of zeros, and they are not inverses. I guess we could just leave that one there, huh? And I think the bottom one works out. This time it's pretty nice. It's tough to get a matrix that has an inverse without any fractions involved. So this one's pretty tough. It's a rare occurrence here. Let's check it out. If you want to push pause and try this one on your own because it does not have any fractions, it might be a little bit friendlier than that. Go ahead and try. So we got 3 and negative 2 for 1. Row column, 6 minus 6 for 0. Row column, negative 1 plus 1 for a 0. And row with a column, negative 2 plus 3 for a 1 there. 1, 0, 0, 1. Yes. Inverses. All right. So the front side, you were given two matrices and you had a test to see if they were inverses using that property, that inverses should multiply to 1, 0, 0, 1. Back side. On the back side, you are going to learn how to come up with an inverse for a given matrix. To find the inverse of a 2 by 2 matrix, we need the determinant, which is the difference of the diagonals. Okay, so for some generic matrix A, B, C, D, the determinant is A times D minus B times C. AD minus BC. And that will be on the quiz or a test. It might not say determinant equals, but this little piece here should be on there. So how does that look for us in a matrix? So we're going to go 7 times negative 1 minus negative 5 times 2. So we'll have negative 7 minus negative 10. Minus negative is a plus. Equals 3. All right, so our determinant is 3. And there will be some problems on your homework that's all it asks for. Here's a matrix, find the determinant. The next level up from that is to find the inverse. So for some inverse of a generic matrix A, B, C, D, we're going to do 1 over the determinant times, pay attention to this, A and D flip-flop spots. So D goes up to the top left corner, A goes down to the bottom left corner or bottom right corner. And B and C change their signs. They don't move, they just change their signs. And a negative here does not mean that it's going to be negative. It means opposite sign or change the sign from what it was. Okay, so let's try it out. Notice that these two are the same matrix. So our determinant for this one is 3. So to find our inverse, we'll go 1 over 3. Okay, these two flip-flop spots, negative 1, 7, and then these two change their signs. So negative 5 is now a positive 5, and positive 2 is now a negative 2. Okay, and let's multiply that 1/3 into all of them. So we got negative 1/3 in the top left, positive 5/3 in the top right. negative 2/3 in the bottom left, and 7/3 in the bottom right. Okay, there we go. Okay, you know what's coming next. You got this one on your own. Give it a shot. Push pause and give it a try. All right, let's see how we did. So for our determinant, we got 6 minus negative 4. So our determinant's going to be 10. So we're going to go 1 over 10. These two flip-flop. These two are changing signs. Negative 1, positive 4. 3/10, 4/10, negative 1/10, 2/10. Okay, and we're in Algebra 2. It's an advanced math course. We can reduce fractions. Four-tenths is going to reduce to 2/5, and 2/10 is 1/5. All right. There we go. One more to go. Let's see how this one works. 2, 4, 1, 2. Let's find the inverse. We need to start with the determinant. So we got 2 times 2, that's 4. Minus 4 times 1 is also 4. That's 0. Uh-oh. We'd be doing 1 over 0 times a matrix. Can we divide by 0? We cannot divide by 0. So that's going to be undefined. And that's going to mean for us that there is no inverse. No inverse possible. Or just no inverse. Okay? All right, folks, there it is. Thanks for watching. Good luck out there. Let me know if you need any extra help. We'll see you next time.